So, dear students, today we are going to start our third chapter, that is motion in a straight line. So, motion in a straight line. So, motion in a straight line is also known as rectilinear motion. It is also known as rectilinear motion. The rectilinear motion is actually motion in a straight line. Similarly, we are going to study the motion. In this chapter we are going to study the motion. We are going to study the motion, but we do not bother about what is causing motion. For example, suppose I have a matchbox, this matchbox here. So when it is moving, we called this body to be in a motion. We called this matchbox to be in a motion. So we will study that particular motion. But if you see clearly, what you will see is my hand or my finger is actually causing the motion here. Okay? But in this study, in this particular chapter, we do not bother about my finger, or we do not bother why this body is moving, what makes this body to move. So in my example, my finger is making the body to move, but in this chapter we won't bother about my finger, or we don't bother about what is actually causing the motion. We just study the motion part of the body only. It is moving with certain velocity, it is moved by certain distance, and we do not bother about what is causing this particular motion. So this type of motion, the motion in which we do not consider, or the study of motion in which we do not consider what is causing the motion has a particular term. Okay, this study has a particular term. The study of motion in which we do not consider what is causing the motion, or we do not bother about what is causing the motion, that particular study is known as kinematics. That study is known as kinematics. So basically we are going to study kinematics. So the particular chapter, this particular chapter, or the following chapters which I am going to teach you later on, are dealt with kinematics. So kinematics is a study of motion in which we do not consider what is causing motion actually. So first, we are going to clear some basic concept about kinematics, inside the kinematics, and they are: first one is position of an object, or just position. So what actually position is? So position is actually the it is a particular place at which the body lies. So what gives in mathematics or in physics, what gives us positions? So positions are basically given by coordinates. For example, suppose I have a ball this way. So I have to specify the position of this ball, where this particular ball lies. So what we will do in mathematics, we will just make a straight line this way, and I'll give 0 to be origin, this point to be origin, You can give origin to any point. You can give origin to this point, or you can draw a line this way and give origin to here, or you can draw the line this way. But line should be straight because we are dealing with rectilinear straight line motion. So you can draw a line here and give origin here, or you can give origin here in this line itself. So this is origin, and this is 1, this is 2, this is 3, this is 4, and suppose these are in centimeters. So now if I ask you what is the position of the body, or what is the position of the ball, so you probably say it is 4 centimeter from the origin to the right. That means it is on the right side of the origin, and it is 4 centimeter from the origin. So this particular specification of the ball, I have given you in one dimension. Okay, so this particular specification is one dimensional because we have just given the position of the ball by one coordinate, that is 4. The ball is at 4 centimeter. But what if I told you the ball is on the paper? So but what if I told you have a paper this way? So this is our first one dimensional. So second will be two dimensional coordinates. So first one is one dimensional coordinates. So in two dimensional coordinates, let us consider a sheet of paper, and I have given you a small very point. You can consider this to be a ball also. Now if I asked you what is the position of this particular point on the paper, now what you will do? Now you are not allowed to draw any lines now. You have to specify the point with respect to this paper itself. You are not allowed to add all the lines. You need to specify the position of the point with respect to this paper only. So what you will do? You will give this particular vertex to be the origin. You draw lines this way. So this is 1, this is 2, this is 3, this is 4, and this is 5. Similarly, this is 1, this is 2, this is 3, and this is 4. That means now the position of the ball here is specified by two coordinates, one along x direction and one along y direction. Now if I suppose to specify the position of the point P, then I'll say it is at 5 at x-axis and 4 at y-axis. That means 5, 4 is the coordinate of the point P. Now similarly, another coordinate is three-dimensional coordinates. Three-dimensional coordinates. Three-dimensional coordinates. So now imagine a room now. Imagine a room now. That's right. Let us imagine a room now, or a box, anything. Now if I ask you, the point or the ball is inside the box, but it is in the air itself. It hasn't touched any surface of the box. Okay? Or let us consider a room, and this is a fan. You can consider a room, and this particular dot is a fan. Fan is suspended in the air inside the room. Now if I ask you what is the position of the fan, what you'll do? Now you're not allowed to draw any other lines here. That means a single point do not specify the position of the fan. So what you'll do? You give this vertex to be origin, and let this to be an x-axis, and let this to be an y-axis, and this to be z-axis. So you have drawn three axes and suppose these are some points. So this is 7, let us take, and let this point to be for y-axis. Okay, this for z-axis it is some point 6 here, and for y let it to be some let it to be now it's difficult for me to draw the third coordinate. Okay, with this it's 4. Suppose you have a, you can imagine a fan, okay, and you can give the length and the breadth of the your room to be x and y axis, and the height of the room to be z axis, and the line from the fan perpendicular to each axis will be the coordinates of the fan, or the position of the fan. In simple, I can draw this to be like this. It is difficult to show you. You can imagine these things. Okay. So this is the point. This is x. This is y. This is z. So this, if this is the point on the x-axis, and this is the point on the y-axis, then the height of this be my z-axis. So for a point in three dimension, there will be 3 coordinates necessary to specify the position of the point on an object. So let this to be 1, this to be 2, and this to be 4. Then the position of the point P will be x-axis is 1, y-axis is 2, and z-axis is 4. So this is the position of the point on the 3 dimension or in space. Now I'll give you certain homeworks regarding position. What should I give to you is I don't know. Okay. So you don't need to calculate it. Actually, you don't need to measure it. So the homework will be without measuring. You can give the value of the dimension to be 2 on your own. So don't measure the dimension. Actually, just give me the rough data or rough values of this particular homework, and the homework is specify the first one. Okay, I give you 3 homeworks. So first homework is specify the coordinate of okay, give me some time. Specify the coordinates of whatever, I don't know. Okay, so I'll just give you one homework. Specify the coordinate of your bulb in your room using a suitable graph. So you don't need to draw the picture of your room. You just need to show the bulb using graph. Graph means you need to draw 3 axes, that is x, y and z. So in x, y and z axis you need to draw a suitable figure. Okay, that figure should be very understandable, and you need to specify the position of the bulb in that particular graph. So this is very interesting. This will be very interesting for the artists in our class. I hope so. But I expect everybody will send the homeworks to me in time. So this is it for today. We will continue our class tomorrow. Thank you.